Assalamualaikum and greetings. Today we will be present for innovation, competition and exhibition INCEX, Inovasi Digital Pemashu Industri Berevolusi with title Motorized Walker for Stability and Balancing. My name is Hainani binti Cik and I will be the presenter for today, and my group members are Puan Surani binti Ilyas and Encik Yaakob bin Omar. For project background, Biomechanics with code BEU40143 course is designed as an introductory course to educate kinesiology students on the basic principles of biomechanics and their applications to human movement. In addition, this course will involve in developing the theoretical knowledge relevant to biomechanics practice, which covers the analysis of efficient movement through a study of mechanical and anatomical principles. Learning outcomes for the course demonstrate the techniques used to quantitatively analyze human movement while acquire introductory skills in using these methods. There are three project purposes, which are as follows. First, to produce modern equipment to quantitatively analyze human movement with the concept of integrated teaching in the era of Industrial Revolution 4.0. Second, to produce a simpler and more effective learning environment as students more easily understand the theoretical concept of gait. And third, to create a safe tool to do learning activities regarding walking style and physical principles underpinning biomechanics and their applications to human movement. Comparing with equipment available in lab as shown in this slide, the innovated foldable motorized walker for stability and balancing is easy to understand because it is not too complicated and have a connection with the application on the smartphone. The concept used in the implementation of this project is project-based learning (PBL) by using Arduino that has helped give students the opportunity to master contextual understanding, and software minimizes the time required for data collection. This equipment can provide skills to students to obtain gait analysis and human movement analysis. Gait patterns such as cadence, step length and velocity are studied. These are the rationale of innovation development. In terms of operation, it is more easier to understand the innovated tools compared to the current gait analysis lab. Then, for the manual equipment, in innovated tool, user or student can only use application installed on the smartphone. Meanwhile, in the current gait analysis lab, user or student need to understand the function of equipment in the lab before conducting experiments. Next, user or student only need a short period of time in using innovated tool compared to the current gait analysis, where it took longer time. Other than that, application for innovated tools is a free source, but with current gait analysis lab, user or student need a license software to perform comprehensive data analysis. Therefore, the innovated tools use very low costing compared to the current gait analysis lab. Target user are for students of Bachelor Electronic Engineering Technology, Medical Electronic, who take BEU 40143 Biomechanics. It aims to provide modern tools for students to practice the theories that have been learned during the lecture session. Students' competence will lead to the level of mastery of knowledge in the theory and understand concept more easily and effectively. It is also contribute to the research in gait stability, and it can be used as one of the tools or equipment in rehabilitation center. Problem solving related to the use of laboratory equipment and existing teaching materials is the basis for the next stage in design. At this stage, analyses are conducted to identify the problem and how to solve it as shown in slide. The purpose of this process is to ensure that the instructional design that will be produced meet the needs and desires of students. The problems that occurs are no special laboratory equipment for biomechanics course, and the solution is the use of equipment for implementation of assessment in the practical elements. Second problem, the preparation and maintenance of biomedical equipment requires high cost. As a solution, production of innovative products that can be tools in practical implementation is used. Next, face-to-face learning needs to be controlled during a COVID-19 pandemic, and to overcome this, hybrid learning needs to be done to ensure smooth learning activities. Besides, the connection between theory and practical cannot be shown, while integrated learning can increase students' understanding. And last but not least, no special laboratory equipment for biomechanics course. As the solution, the use of equipment for implementation of assessment in the practical element is used. The figure shows project design from side and front view. It has 2 brakes, 2 grips, foldable part, 2 motorized system and 4 wheels. Foldable motorized walker is created by using components such as DC gear motor, Bluetooth module, 14.7V rechargeable DC battery, walker, Arduino Uno, motor driver, jumper wires and software which is consists of Arduino IDE and Blink application. Students only need to install the detector on a wheelchair and then test on obtained data and result within a specified period using the application that has been downloaded. Figure shows the improved motorized system block diagram. These photos here are taken from the beginning until the end of product of foldable motorized walker for stability and balancing. Figure shows the procedures made in order to conduct an experimental procedure. The procedure will begin from before using MotoWAC until after using MotoWAC. The implementation phase refers to the development and design of instruction that has been prepared and will be implemented to students. The results that have been developed in the development phase will be tested. This implementation will involve 4th semester students who will use this equipment during the implementation of the case study for BEU 40143 Biomechanics. Next for operation video.
First of all, install Blink application. In Blink application, D13 is used to turn on the LED. D7, D8, D4 and D9 will be used to control the direction of the device. Slider 1 and Slider 2 will be used to control the speed of the DC motor. Open the foldable part of the device. Make sure the safety lock is tightened. Turn on the switch button and the Bluetooth module will start blinking. Open Blink application. Select Bluetooth and ready to pair to the device. Test the LED as an indicator. LED will turn on when the device is connected. Then we test the functionality of the device. Place the smartphone on the phone holder. Then we move to the project demonstration.
For impact of project, Figure 1 shows respondents were tested by giving questions to calculate cadence and stride length using the principles used in Gait Analysis. 3% of the students on the scale were excellent, while 10% of the respondents on the weak scale were mastering the principle used. After explaining the use of this motorized walker and being proficient in using it, respondents were tested by asking the similar questions. Then, the respondents were given similar and necessary questions by using a motorized walker. Respondents need to compare the measurement result obtained through the data from the use of the application with the theoretical calculation values. The research found that 33% of the respondents were on an excellent net scale and only 7% of the respondents were on a stratified scale. Impact of project for suitability of motorized walker, MotoWAC as a TGA. As we can see from the graph, 94.17% where our respondents mostly agrees motorized walker is suitable to be used as an integrated learning, while 90.83% believe that motorized walker can be a tool in practical implementation, and 85.83% about the usage of MotoWAC is safe and suitable to be used equipment in for the implementation of assessment in a practical element. Impact of project for application design and display, 94.17% as shown in figure 3 is about the application of Blink, whether the use of Blink for motorized walker is very helpful in this process. While 93.3%, which is question 3, that is about the relevancy of Blink to be used nowadays, and 70.6%, which is question 2, are about the sufficiency of information display and the combination of Blink. Significance of project in environmental aspect. First, application IoT, greener and smarter environment. Second, low power wirelessly connected sensors. Third, environmental protection by reducing waste, lowering greenhouse gas emissions, and conserving energy at home, work, and on the road. And fourth, recycle things can reduce waste and create green technology. Significance of project in economical aspect. It can enhance rehabilitation medical device industry besides bringing the future of healthcare to measure. In addition, more investors and funds will join for digital health. This foldable motorized walker for stability and balancing innovation has been able to help contribute to the achievement in the JPP-KK strategic plan and the PSA action plan. In first, innovation in application is to cultivate innovation activities under innovation product activities. It is registered for My IPO. And second, activity indicators with applied innovation products are recognized by the industry product development through collaboration with a biomedical supplier company, Sasmed Sdn Bhd. Further works are recommended to improve the effectiveness of foldable motorized walker. First, for DC motor, recommend to using high torque DC motor which make it perfect for use in applications that are designed to move heavy loads. And second, for networking, Wi-Fi is used instead of Bluetooth. Node MCU ESP8266 takes 2 seconds to connect to the device as compared to the HC06, which takes 22 seconds. This indicates that Wi-Fi connection is faster than Bluetooth. Make a connection with the electromyograph (EMG) sensor for a diagnostic procedure to assess the health of muscles and the nerve cells through the value of the voltage. As the conclusion, Motorized Walker as a teaching aid tool has been developed to assist students and instructors in the teaching and learning process. This innovation also creating and boosting students' thinking in the scope of innovation creative in absorbing knowledge and skills through the testing of product results. Motorized Walker uses Arduino software and Blink application helps students and lecturers in improving achievement and more motivated in learning skill in research and industry. That's all from us. Thank you.